That, I guess we'll go ahead and get started. Are you ready in the back? Okay, good. So, as you can see, my name is Pete Baselici. I work for a company and do basically all things integration for a manufacturer of lighting control products. I've been involved in the BACnet process for quite a long time, at least 15 years or so. Started with a previous manufacturer that I worked for, BACnet products, and been involved in energy code. I've been on the ASHRAE 90.1 committee since, I don't know, 2002 or something like that. So that's basically leads us to what we're going to talk about today. And basically what I'm looking at doing with this presentation is kind of weaving together, as you can see, the technology, energy codes, and lighting controls, and kind of weaving the story there as to how they interrelate with each other, because they clearly do. And lighting controls have changed over the years to remain in alignment with energy codes, and we want to talk about that a little bit and see how that lines up. And then I do want to weave in the role that BACnet has played in the past to get us to where we are today, and talk a little bit about where BACnet is going, because BACnet has actually just added some new features in the latest version to cover lighting controls. So we'll cover that just briefly. I'm not going to cover it from a real technical standpoint, so don't worry about that. Oh, I guess I better start my timer, huh? Okay. So I want to start out with just a couple of quick milestones in the energy code. I'm not going to spend a lot of time on this, but we're talking about ASHRAE 90.1 is the code that I'm involved with. There are other codes, Title 24, IECC, but I'm specifically going to be talking about the 90.1 mostly. And really a key turning point was prior to 1999 version when it went to continuous maintenance. And that's when controls really started coming into play in the energy code. Prior to that, it was pretty much things other than controls that were really driving the code, setting the basis for the code requirements later on. In 2007, the first requirements for occupancy sensors. Occupancy sensors have been mentioned in the code since almost the beginning, but they were never required. They were an optional. So in 2007, they became required. And in 2010 is when things exploded. And we're going to see that a whole bunch of requirements came into the 2010 version. And the reason 2010 is kind of important is because right now it's the version that is pretty much being adopted by states. We're about to publish the 2013 standard, but again, it'll be a while before that actually gets down to the state level. So 2010 is really the version right now that is of significance for us to look at. And as you can see, bi-level lighting, manual on, receptacle control, plug load control has come into play, daylight harvesting, right, and more restrictions on renovations. Today, there are, it used to be 50%. You change 50% of the lighting in space, you had to bring it up to code. Now only 10%. So basically, just about every renovation that's done in a building now will have to be brought up to code, and it's going to have to include the controls requirements, not just the lighting power density. So it's a pretty significant change because the majority of the building stock out there that we deal with really is renovation, not new construction. That's the big number. So that's an important. So if we look at the way this lines up chronologically, okay, I want to start bringing technology into the story here. I mean, if we look at, that's the line there is kind of 1999, and to the left of that for 20 years or so, going out to, basically starting out at the left. For those of you who are in building controls, we're talking pneumatics, right, through the 70s and into the 80s. And then today, of course, everything is digital, right? We're in the cloud, whatever that is, wherever that is, but, right? I mean, so we've come a long way since pneumatic controls right on up to where we are today. And if you look at this chart, was kind of showing the energy savings that the code is delivering, basically based on stringency. And you can see the big jump at around the 1999 line, and to the right is when controls kicked in, digital kicked in, technology kicked in, and you can see that the big savings is to the right of the line. To the left of the line was very slow and meticulous, right? So its standard was only published every 10 years, right? Remember continuous maintenance. Now every 3 years the standard gets published because it has to keep up with what's going on technology-wise and whoever. And a big driver was the Department of Energy that mandated that the 2010 standard will be 30% more stringent than the 2004. And I got to tell you, I sat in that meeting when that was announced, and it was a big deal. You know, are we going to throw out cost effectiveness? Are we going to throw out consensus? You know, and no, none of those got thrown out, and we made it. It was tough. So anyway, that's just kind of a quick chronological look. So technology, energy code, right? Energy code is speeding up. So what's driving what? Chicken or the egg, right? Is the code driving technology, or is technology allowing the code to accelerate? And really, it's really a synergistic thing. It's both, okay? The fact of the matter is that we have to have controls that are available on the market to meet the requirements of the energy code, right, in order for it to be viable. And clearly, manufacturers are going to react to what's happening with the code. As the code becomes more stringent, as manufacturers, we want to make our products more attractive to you, the customers, right, to meet the code. And so competitive edge comes into play, and we start improving our products to take advantage of where the code is. So it's very much a circular path here. So as we start to talk about controls, and that's obviously the part of the theme here, back around that 1999 date, the state of the art, if you will, was to meet the automatic shut-off requirements. Okay, we now have to somehow automatically turn off the lights in a building. State of the art was a relay panel, and they came in all different flavors, and most of the lighting control manufacturer names that you know today all made one. And things were pretty. It was pretty easy back then because you basically had circuit level control. You could have a clock built into your panel, or it could be interfaced to the building automation system to provide a timed feature, and you just basically had to turn the lights off at the end of the day. And that's really where we were for quite some time with the lighting control panel. And basically, the code came about, you know, controlling 2,500 square feet. That's roughly one circuit's worth of 277-volt lighting that meets the energy code from a LPD standpoint. Lighting power density. I tend to throw some of these acronyms around, and in a lighting crowd, everybody knows what an LPD is, right? But it's lighting power density. So anyway, it wasn't, at this time, you know, digital was around, okay? We were in the digital age, and these panels were able to communicate. Most manufacturers had a proprietary bus of some sort that could connect these panels together. I remember back when I started working for a previous manufacturer, I guess it was '89, I started right in the early '90s. We started immediately, we're developing BACnet protocol for our panel systems. I can remember the big panel of the day was GE, General Electric, and I remember Johnson Controls N2 bus. Everybody remember N2 bus? You know, there was an interface, and that was kind of my first experience with integrating lighting control panels to the building automation system. But it wasn't long after that we started developing the BACnet interface. And I know those of you who've been around BACnet for a while have seen this graphic before. It dates back to a Michael Newman presentation at Purdue University. I don't remember the year, but it was a long time ago, like 15 years ago. The point here is that BACnet is a protocol, and you just heard a lot about BACnet, you know, those of you who were in the previous presentation. It's very, very flexible, and the fact of the matter is, though, it never mentions lighting. The word lighting may be in there somewhere, but there certainly is no provisions in BACnet for lighting. There wasn't for security, as you know, either. But you know, it is a flexible protocol, so we've been able to adapt it to work with lighting and security and elevator controls and all kinds of other things that weren't specifically mentioned in the standard. You know, it's not a stretch to think about a relay, which is a binary device, right? It's on or it's off. BACnet has a BO object, right? A binary output object. And it's very easy to create an interface in a panel that allows BACnet to address the relays as binary output objects. BO objects have properties, allows us to name that relay. And you know, those are some screenshots actually off of a workstation that I think it was an Allerton workstation. It doesn't really matter. But you can see that basically having a relay, which is a binary device being controlled by BACnet as a BO object, is pretty simple. Okay? However, there are a number of things in lighting control that are necessary to make an effective lighting control scenario. If we were to control every relay in a building separately with a BO object, the point count for that project would probably at least double, maybe triple over the HVAC. I mean, there are just a lot of points when you start talking about lighting. So grouping of those loads together so we can use one object to address an entire corridor or outdoor lighting as one object. BACnet doesn't provide for that, okay? So these become local matters for the different manufacturers. How we group those relays together in our panel and offer them to the BAS as a single BACnet object is a local matter for each manufacturer. So this is something that was never addressed in the original BACnet standard. And this goes right on down the line. The override switch logic, you know, with lighting, we have to have overrides, you know, and it's very important in lighting that override switches be connected directly to the lighting control panel because, you know, we need real-time gratification. You press a light switch, you expect the lights to switch. You adjust the thermostat, you'll give it some slack, right, as to when you feel the cooler or the warmer air. But all of these things, you know, blink warn, blinking the lights before we turn them off, fading, preset scenes, these are all things we use in lighting control that aren't specifically addressed in BACnet. So we all had to find ways to take that BO object, have that be the primary interface, but be able to apply all of these other things. And again, it became a local matter for the different manufacturers of the different panels. Okay? We'll talk how this has become standardized toward the end. So the relay panel back in 1999, right, was our primary basis for design. Occupancy sensors were around. They were in the standard as optional devices. But look at where we are today. It is totally flipped, okay? The occupancy sensor now is the basis for design, and not only just an occupancy sensor, but an occupancy sensor with a pretty advanced sequence of operation. And the relay panel is now relegated to controlling outdoor lighting, anything that's, you know, basically full circuit control, big warehouses, things like that. And really, so the occupancy sensor is really the, basically it's flip-flopped. So what's driving that? Well, it's, you know, it's the code that's driving that, right? And the first thing I mentioned in 2010, multi-level lighting, okay? It's now, if you're from California, this is nothing new because you've had 2 light switches in all of your spaces for a long time, but it's not for the rest of the country. So bi-level lighting, a minimum of at least bi-level lighting is now in the code and has to be recognized. And every time we talk about this subject, it always comes up about dimming. You know, wouldn't it be better to just dim the lights, you know, the bi-level switch? Yes, it would. I'm a big fan of dimming. I like dimming. However, most of our lighting today is fluorescent. And dimming fluorescent is not inexpensive, okay? It is very expensive to dim fluorescent. And so really the best return on investment is going to come in with the bi-level switching. You know, we can gain savings. Now there's certain places where dimming is really almost mandatory. When we talk about daylight harvesting, and we'll mention daylight harvesting again, But that's someplace where dimming is almost necessary, because if you switch off lights, people tend to notice. If you just dim them, they don't notice. So anyway, I'm kind of jumping ahead. But as it says there on the screen, with the new LED technology that's being used in lighting today, dimming is going to become more everyday commonplace, because the drivers that are now being used for these LED fixtures, for the most part, are dimmable. So you buy an LED fixture for whatever it costs, and you either choose to dim it or not dim it, and you're not going to have to pay extra in most cases to dim it. The problem right now is LED lighting is still fairly expensive, so we're not using it for the everyday fixtures in our buildings yet. But it's coming very, very quickly. Manual on. Occupancy sensors traditionally are, you know them as you walk in the room, the lights come on, you leave the room, and the lights go off. You've all walked into a restroom and had the lights come on automatically. Well, we've never saved any energy by turning the lights on, right? You only save energy by turning the lights off. When you think about going in your kitchen at night to get a snack, right? You have to turn the lights on. They don't turn on automatically unless you're a control geek and have a occupancy sensor in your kitchen. Turning the lights on automatically doesn't save energy, so the code now, manual on. However, recognizes the code is very flexible. If you want to have automatic on for any reason, you're allowed to, but you can only turn on 50% of the lights automatically. Remember, you got bi-level lighting, right? If I want auto on, I can turn. Now we're starting to see the sequence of operation getting more complex, right? It's no longer just a sensor and a power pack. Daylight harvesting is now required in the code, both for side lighting and for top lighting. In fact, the energy code now requires certain buildings to have skylights, right? So we're not only requiring the controls, but we're also requiring certain class of buildings to have skylights, basically big box, retail and warehouse, whatever. And if you have skylights, then you have to have controls. If you have windows that meet a certain criteria in your rooms, then you have to have daylight harvesting as part of your. So again, the sequence of operation simply to meet the energy code is getting more complex. Receptacle control. We're talking about plug loads here. The energy code now requires that in certain space types, that 50% of the receptacles in the room must be equipped with automatic shutoff. Okay? Think about that. I mean, that is a major jump. I think it was, I have a note here. PNNL published some data that said that plug loads in typical, average plug loads in typical office scenarios are reaching 0.88 watts per square foot. Now, the energy code says you can put 1 watt per square foot of lighting in an office, so you've got almost as much plug load now in a typical office environment as you have lighting load. So it's significant, right? And again, the CLTC information is saying that if you add lighting and plug load together, it's now 50% of the energy, electrical energy used in the class of office space that they did the studies on. So pretty significant numbers there. So the energy code has recognized this, and you now have to turn off. And of course, we're talking about things like your monitors, your task lights, your printer, your coffee cup warmer, all that kind of stuff. We're not talking about turning off your CPUs, right? And integration with the HVAC system. Now, ASHRAE 90.1 does not require integration to the yet, okay? But I found out this year that California Title 24, okay? California has always kind of been one step ahead of 90.1. Beginning January 1st, buildings over 10,000 square feet in the state of California must have occupant-sensitive HVAC controls, okay? And that's for temperature and for ventilation. Now, that doesn't mean they have to be digital. They don't have to be BACnet. They have to be occupant sensitive. I can connect an occupancy sensor with a relay in it to my BAS system. However, they also say that lighting controls must be able to respond to a digital demand response signal, right? And do a certain amount of setback and whatever. So you put the two together, and basically what you're saying is that buildings over 100,000 square feet in the state of California after January 1st will have lighting integrated to the building automation system. Because the the demand response thing is huge. You're not going to have your lighting controls connected directly to the power company. What's going to be connected to the power company in some way is going to be the building automation system. So the building automation system is going to have to get that demand response actuation down to the lighting controls. Hence, they're going to have to be integrated. So that's basically the way they've driven it in California. They haven't said you had to integrate it. They basically gave you requirements that are forcing you to integrate the light. So that's pretty significant. I would predict that we're going to see this in 90.1 as well going forward. I can predict it pretty strong because I'm going to propose it. But when we talk about integration to lighting with the HVAC, I found this quote by Paul Ehrlich. I haven't seen Paul. I don't know if he's here. But Paul is with the Building Intelligence Group. He writes a regular column for Engineered Systems. And bear with me, I'm just going to read it. It's just 3 sentences long. But we prefer to use a lighting control architecture that is highly distributed and readily integrated. These systems generally have a controller that is mounted in the zone, often in a junction box or directly to a fixture. The controller is capable of doing local control functions, parenthetically occupancy, vacancy control, daylight harvesting, bi-level control, as well as time of day scheduling and status through the BAS integration. Options for connecting include wired, wireless, powerline carrier, and most of these systems will readily integrate using open protocols such as BACnet. So I think that's a pretty profound statement, and it pretty much says exactly what mimics or what I'm trying to get across up here. But what is he talking about? Let's continue on, and I think it'll become clear. So we just discussed how we started with low voltage relay panels. We moved through occupancy sensors, and because the control sequence is getting so complex, it's getting very difficult to use the old occupancy sensors that we used to use now to do the new sequences of operations that are required. I mean, this diagram is self-explanatory. Right? Let me explain. So this is basically what we have today to meet the energy code. Remember, we got, I think there's a laser pointer here. Yeah. So we have to have 2 lighting loads in the space, a minimum of 2 lighting loads. Sorry. And we have 2 lighting loads. We'll need 2 switches, and those are going to have to be low voltage switches because they have to interact with the other low voltage components in the space. Of course, the occupancy sensor. The occupancy sensor may be connected to the HVAC via dry contact closure. I mean, that's done a lot today. Certain spaces will have to have the daylight sensor. If you have a daylight sensor, you certainly don't want it to turn the lights on if the space is not occupied, right? So there has to be a logical relationship with the occupancy of the space. If I have daylight sensor, I may or may not want it to be able to be overridden by the user. Again, there's an interrelationship between the controls that has to be met, and we're going to meet this, digitally. We're not going to meet this with wire nuts and connections, right? And just kind of to illustrate that, this is this is what we just showed, except this doesn't even include the receptacle control. But you've got 2 lighting loads, right? You need 2 relays of sorts, the occupancy sensor, and then 2 low voltage switches. Remember, you can't do this with line voltage switches. It has to be low voltage switches. So, in the old days, and I got my, I always like to do a little, live demonstration here. It always livens things up. So in the old days, we had an occupancy sensor and a power pack, right? A couple of low voltage connections, connect them together. Lights turn on, lights turn off. No big deal. Everybody's happy. But now, what we said is, there has to be bi-level switching, so it means we're going to need at least 2 relays, unless we're going to do dimming, right? So now we have the 2 relays. They've got to be low voltage switches, can't be line voltage to do what we have to do. So now we have a couple of low voltage switches. You see what's happening here? All right? This will work. This will meet the code. I guarantee this will meet the code if you can get it wired. And remember, it's not just this connected to this. There's a piece of interceding wire in between, right, that may be a different color altogether, right? So this is not sustainable. And remember I told you how manufacturers will react to the code to improve the products and whatnot. So indeed, that's what's happened, is manufacturers have reacted to this, and we've now all improved our products to be able to meet this complex sequence of operation and you know, have a sustainable product. And how we've done it is just looking at my time, good. We've done it obviously by making the controls intelligent, right? The controls are now smart, and different manufacturers have done this different ways. Some are using wireless, some are using wired, still using wires, but in a different way. And it's crap, sorry. But it's, I keep hitting the wrong button. It's technology, you know, this technology stuff, I'm just too old for this. And it's interesting to note that, you know, we talk about the controls going from this to digital, and the controls are actually not getting less expensive, okay? The controls really are getting maybe even a little bit more expensive, but they're providing a lot more value, okay? So you're getting a lot more for your money now with the money you're spending on the controls. And we can start talking about things like return on investment, especially when you consider the total installed cost of putting these digital controls in as opposed to the old analog, the ease of installation and the sustainability and whatnot. So it's an important point, right? They're not getting cheaper, and especially if you're taking the test, it's an important point. Let's do a little comparison, okay? We always have to compare wired and wireless. And again, I'm trying to keep this very, what's the proper term? I don't want to show any favoritism. I want to try to be absolutely honest about the comparison. You've all used wireless, you've all used wired products. Certainly wireless can solve application problems. I mean, there's no question about that. I've got a concrete ceiling, I've got a ceiling with asbestos above it, I can't penetrate it, I need, to put a device there that isn't going to have to penetrate the ceiling, and I can't get a wire there. When we talk about lighting control, wireless is really reduced wiring. And this is where part of the misconception people have about wireless is. If I'm going to put a sensor on a piece of equipment to measure the temperature and send that to a controller, that could be very straightforward. I put a sensor on there and it just transmits the data, right? Well, remember, with lighting, we're dealing with line voltage control. Somewhere, there's a device that has to switch that 277 volt lighting. It may have to dim it. There may be 0 to 10 volt wires involved to doing the dimming that are within the light fixtures and the equipment itself. So really, wireless is reduced wiring, okay? That device there is a wireless interface for a lighting control system, right? So just be aware that wireless is not necessarily wireless. Anytime we do wireless, of course, you're going to have one more step in commissioning. We're going to have to commission the radios. We're going to have to bind the devices together. Depending upon manufacturer, it could be very easy. This is one that people are just kind of flossing over, okay? Wireless devices are very power sensitive, right? You don't have a lot of power to play with, right? So technologies that use a lot of power, such as ultrasonic, right? The best technology for doing occupancy sensing is ultrasonic. It uses too much power. You will not find a wireless ultrasonic sensor. It can't be done, okay? We're using batteries, we're using photovoltaics to charge the devices, or piezoelectric, right? We're using that technology. None of those will support the power requirements of other than passive occupancy sensors. So those spaces where the best practice would say use an ultrasonic sensor, you can't. I may have to use 2 infrareds or whatever to make up for that. So that's just something that tends to get flossed over when we talk about our wireless products. Battery maintenance certainly is an issue. Some of these products are using batteries. Some of the manufacturers say we guarantee them for 10 years. 10 years comes to an end at some point, okay? So there is that consideration. And then other sustainability concerns. I put in wireless controls, and then next door, a new tenant moves in, building Van de Graaff generators or, radar systems or something that, who knows. that can interfere with the radio. So I mean, there's always that as a concern as well. On the wired side, we're really not talking about the wires we were looking at before. We're talking about pre-terminated cables, and pretty much all the manufacturers today of lighting controls that are going down this path, for the most part, are using basic Cat5e patch cables, readily available, and easy way to eliminate all those wiring connections, and also get a little data between those devices as well. Most cases, I don't know of any of of the lighting folks who are putting Ethernet over this between the devices. We're just simply using the Cat5e for the convenience of the wiring and the communication. And certainly if you have an accessible ceiling, it's a very simple process of connecting devices together. Click, click, that's all there is to it, as long as you have accessible ceiling and don't need to go wireless. It can reduce commissioning. In a lot of cases, these devices, there's one less step in commissioning. You don't have to commission the radios. And there are no performance limitations, okay? You can use ultrasonic and dual technology sensors that various manufacturers put out and not have to worry about, not having enough power to use them. Of course, obviously there's no battery maintenance, and then the sustainability, reliability issue we just addressed. Also, it goes away. So if we take the fact now that we have smart communicating controls, lighting controls in our room, we now can talk about integration to the building automation system at a different level, right? So now instead of that occupancy sensor having a contact closure over to the BAS system, there now can be a digital connection over to the BAS system, right? And BACnet could come into play. I want to know the status of the lights. I want to put them in my graphic display. Maybe I want to be able to override them, all this stuff. But now that the controls are all digital, they're all communicating, the sky's the limit as far as connecting it to the building automation system, and we'll look at that a little bit. And when we talk about this, there's always the obligatory discussion of why we actually want to do it, right? Well, we all hear the terms high-performance building, intelligent building, smart building, net zero building, all this stuff. Well, obviously, none of this is going to happen unless all the controls in the building are all talking together. I mean, that's almost really a no-brainer, right? And then, but there's some more. There are some other reasons that we might want to do it that are less high and mighty. Obviously, coordinating the occupancy status of the HVAC, security, whatever, with the lighting. And again, this is almost a no-brainer too, because there's no better measure of occupancy of a space as to whether it's lighted or not, right? I mean, you're not going to have an occupied space that's not lighted. Now, you may have an unoccupied space that is lighted, but then you're in contrast with the energy code, right? But so lighting is a good measure of occupancy, so tying it to the building automation system, it becomes a good way to use that occupancy sensor that you already have in the space to let the BAS know whether it needs to condition the space or set it back or ventilate it or whatever. We want to get that lighting power into our graphic displays, our dashboards, our analytics, and all that stuff. I've already mentioned the tie-in with the demand response, right? We got to get the signal from the power company to the BAS, and the integration is how it's going to get to the lighting controls for sure. And then again, codes and legislation, I mentioned what's happening in Title 24, and going forward, I think we're going to see this carry forward into 90.1. So the methodology, we can integrate up at the system level. We've been talking about BACnet IP at that level, or we can integrate down at the room level. Remember, we have smart controls down in the room now, so we can look at doing it either way. Quick look at how the architecture might look at the system level. You've got a complete lighting control system that's bridged over to the BAS system via probably BACnet IP. And then, gateway used to be an ugly term in the BACnet community, but I think gateways have gotten better, and I think there are times, especially in renovation, where the gateway is the only real solution. But in any case, if we're bridging two systems together, there's going to there's probably going to be a gateway involved and an object list and whatever. Not necessarily, we'll talk about a little bit about the pros and cons. Of course, the disadvantages are you have two systems that have to be commissioned separately, and they don't always happen at the same time. I've had this has been a big problem in my world. As the lighting control system gets commissioned, the BAS system gets commissioned, they have to integrate, but they happened at two different times, and there's nobody there at the right time to tie the two systems together. So that's, of course, if you have a single point of connection, you have a potential single point of failure. And there's a lot of BACnet object management that has to happen. All those lighting points have to somehow get organized and presented to the building automation system and then used by the BAS system. They have to understand what they are and what they do. But if you look at the advantages, that same point also shows up in the advantages, because if you're doing this, somebody has to do it. And again, that's another peeve that tends to happen on integrated projects. You see the spec, shall be integrated to the building automation. The lighting shall be integrated to the building automation system. It's a great spec. What is it supposed to do, right? What points are supposed to get integrated, right? So point management is something that has to occur. When you're doing this level of integration, somebody's got to do it. So it becomes both a disadvantage and advantage. It allows us to clear separation, so if there's a problem on one side, it's easy to sort it out. And can be the very, very simple connection between, you have a well-installed, well-designed lighting control system, a well-installed, BAS using BACnet IP, and then it becomes a very simple process to connect the two together. At the room level integration, okay, remember we got our smart devices that are now communicating, so there is the possibility that they can communicate via BACnet, right, and get that direct connection right to the building automation system. We're not going to be at an IP level here. We're down at the field bus level, which for BACnet, as you know, is MSTP, RS-485 type communication. And if you think about it now, if you have a room full of communicating devices that's talking BACnet, the room itself you can think of as a unitary controller, right, an application-specific controller. It has a device object, it has an address, it has an object list, and it's kind of an interesting new concept, where you have a chiller, you have a VAV box, and whatever. Now you can think of the room as being a controller in itself if you have controls that are capable of communicating over BACnet, or at least digitally. So again, the advantages and disadvantages. All BACnet objects get discovered must be managed by the BAS. Well, yeah. So whatever's there is going to get discovered, and you're going to have to use what you want to use and don't use what you don't need to use. But we can integrate one room at a time. We're not depending on infrastructure. We don't have to put an entire network in before we can make the first switch, control the first light, right? It's you can do it one room at a time, integrate one room at a time. And it allows us to use provisions of, I guess the new one is Division 25, used to be 17, were full building control specifications that are going to cross over between lighting and BAS, and it lends itself very, very well to those type of specifications. And of course, there's not going to be a single point of failure. Oh, crap, my timer stopped. Has anybody got reading on the time for me? 10 minutes total? Okay. So, I've already mentioned, modeling with BO objects and how we've used the present value of the BO object to do on and off, but we don't have the blink warn, the time delay, all those other things. We can use analog for dimming, right? We can have an analog object that'll do dimming, but we have no provision for fades and ramps. And right on down the line, multi-state value can do scenes, binary input object can do, but every one of them has all these things that it can't, that aren't in BACnet, and there are more. So the latest version of BACnet, and I don't know how familiar anybody is with the latest printing of BACnet, now includes some new objects and services. I'm going to hit these at a very high level. And just kind of let you know what's happening in the world, the BACnet world, to accommodate lighting. But these new objects and services directly relate to lighting. Lighting is now part of the BACnet standard, okay? The lighting output object, the channel object, the right service group, and the binary lighting output object. And we'll hit them just quickly here. So the lighting output object is primarily taking into account the whole world of lighting control, including dimming. Okay, it's a pretty heavy object, and you know, I mean, the concepts get pretty thick here. You know, you can always use a present value to tell a light what level to be at, 75%. But suppose it's fading. So at what point, you know, so you have to be able to see where it is in the fade. So you now have a tracking level, right? I mean, you have to be able to set your default fade times, all that stuff. The object itself becomes very heavy in terms of the programming requirements and memory requirements but it does allow you to create a BACnet device that is very integratable and programmable even, you know, as we talk about configuration tools and whatnot, as that advances directly through BACnet. But a big part of this is the lighting command. So there's a whole list, and that's just a few of them, things that now there's a complex data structure in there that allows you to actually tell something to go to a level and take this long to get there, right? These kind of concepts that never existed in BACnet before. So we're going to see a whole lot of equipment get developed by manufacturers because this is now part of the standard. The binary lighting output object is basically a lighter weight object used for light control. It's going to be primarily your switching applications. It actually is not in the standard yet. It's out for public review right now, and it'll be in as an addenda to the standard. The channel object, again, this gets fairly a little complex, but the channel object and the right group service work together. And there's the problem statement, right? Think about a big ball. Suppose all these doors were open in this big ballroom, and I have a dimming panel in each corner or whatever, and I want to be able to press a button and have all the lights fade to 50% at the same time. Well, over BACnet, that's almost impossible to do, okay? I'm going to have to send out sequential messages to the various panels, the various objects that represent the dimmers, and those and you're not going to get a totally synchronous response. So what the channel object does is allows us to put an object in each of those devices that now can accept a broadcast command, which is the right group service, which is a broadcast that lets me get that data bang to all four of those panels at the same time, and then within each of those controllers then, as an internal matter, it can take care of getting that to the dimmers within the panel so that everything can get to that 50% at the same time. This has been a big issue. I've been involved in lighting controls and BACnet for a long time, and this didn't take long for this to come up as an issue on one of our projects. So it now takes care of that. So that was a real quick look at some of the new objects. I don't know whether Grant is going to cover any of those tomorrow when he continues the discussion on BACnet here in this room. But at any rate, let's just take the last couple of minutes that we've got here and just kind of review what we've learned, right? We've seen that the energy code has accelerated in recent years, right? It's being developed more quickly now, and it's both taking advantage of technology as it's developed, and it's also driving technology, right? So we see that is a synchronous process there. We talked about dimming and how LEDs, as a technology, LED is going to change our world when they become more commonplace, then dimming is going to become more commonplace. The granularity aspect of requiring a more complicated sequence of operation in the individual spaces, okay, so we have to control smaller spaces and have a more complex sequence of operations where the term, I'm using the granularity comes into play, and that digital rather than cost, right, is really the key driver or the key enabler, right? It's the fact that the controls are now digital, and really cost is not a factor from the standpoint of driving the technology. We've adopted the controls now are not only digital, but they're smart, so we now have the ability to put a group of controls together that are integrated and, distributed intelligence, right? You've all heard that term. A group of controls that can talk together, work together to work out these problems of sequence of operation which of course is going to, is driven by better alignment with the energy code. And of course, we just talked about how that can also affect integration to the building automation system. And then the fact that lighting control now is no longer a stepchild in the building automation world. Okay? It's now officially part of the BACnet standard. It has come of age, if you will, with the new objects. And I don't know that it was really slowing us down, because pretty much in my world, selling, manufacturing and selling lighting controls, any building of any size today, we're dealing with integration. It's become a commonplace, but certainly the new recognition in BACnet and the ability to have new objects. There's a interoperability workshop coming up in Atlanta next month, and I know for a fact that several manufacturers are going to be testing the lighting output object at that. So it's going to be interesting. It'll be fun. So that's basically, I think, where we are. Questions? Yes?
You mentioned earlier fluorescent dimming, much more expensive than LEDs. Is that because the LEDs are going to have a fractional load when they're dimmed?
No, it's really the fact that fluorescent requires special ballast, dimming ballast, and they're very much more expensive than standard switchable ballast. That's really what it is. The drivers for the LED products, the way that they're being designed, it's a DC circuit, so having it be dimmable they're basically inherently dimmable, most of them. So it's not that the LED, it's really the fact that the dimming ballasts for the fluorescent are so expensive. And there was always promise that they were going to get less expensive, and really it's been leapfrogged by the move to LEDs now. And I don't think we're going to see any more development in fluorescent dimming ballasts, because it's all going to be moving toward LED. Yeah.
So that answers
Okay.
the Dolly question, I guess.
Dolly's there. It's always been there, but it has the same issue. The Dolly ballast is a dimming ballast, and it is an expensive ballast. So you have that, that same issue. Dolly can drive LEDs, but do we really need Dolly to drive an LED that's already dimmable? So Dolly's going to be around. It's not going. It's still going to be somewhere. It's going to be a player, but. I don't see it in the mainstream in the U.S. We seem to run into it more in Canada, and Grant, I think Grant probably backed it up. Grant is speaking here tomorrow at the same time, same room. Grant, you want to just say what you're going to be talking about? It'd be the easiest thing to.
Sure, I'm following up. My name is Grant Pachenko, and I'll be following up on this session tomorrow on how to work with multiple manufacturers. Many of you have different manufacturers that you have providing lighting and HVAC and fire and security. And I'll be talking about how to integrate those systems together so it doesn't drive you crazy.
That's important.
Yeah.
Okay, so if no more questions, don't forget to fill out your forms. All right.
Are all your slides available on
Excuse me?
Are all your slides available?
The slides will be available next week, I think is what they said here. Yeah. We also, I'm with Wattstopper, obviously. We have a booth, so come on by and we can talk on a more commercial